So we are talking about the importance on forecasting about weather balloons. Look at how giant this thing is. Some people think they're really small, they're not. It's also filled with hydrogen in some cases, like this one, instead of helium. And what this balloon is going to do is go all the way to the top of the atmosphere with a special instrument on the bottom called a radiosonde and bring back data that we need as forecasters to check and see the conditions of the atmosphere. So there is the assumption, it's not always correct, that the balloon goes exactly from the bottom of the ground to the top of the sky. So we give it some wiggle room. However, we use this to collect important data that we need when forecasting that we cannot get from the models, from the radar, or from the satellites. This is the only way for us to see in real time these variables in the atmosphere. So this is what it prints back out as a skew-T chart for forecasters to interpret from that launch. And what we do is have special balloon launches when necessary to check on conditions. This skew-T that you see here was from a special balloon launch that we had just recently for the tornado outbreak that just occurred. We launched this one to see if the environment would be conducive for producing tornadoes, and in fact it was, because an EF4 originated in Louisiana. So what types of information do we get from that instrument and that radiosonde, and then how do we use it? These are really great examples. So these red and green lines are just simply the temperature and the dew point of the entire atmosphere vertically, which is very important. It starts at the surface and it goes all the way up. Another important variable that we get is wind data. And so we see what the winds are doing, and most importantly, how are they changing with height? Because the way winds change with height tells forecasters and other meteorologists what we can expect weather to do once it hits that environment. And then another product for the wind that's incredibly helpful at a glance is over here is your hodograph. It's actually showing you the same thing. It's how winds are changing with height, but it's plotted in a different way. So a trained meteorologist can look at just the shape of this and have an idea of what type of severe weather you're going to get, which way supercells might move, will you have tornadoes. It's incredibly useful to determine the mode of severe weather. So supercells, a straight line of storms, things of that nature. It's an incredibly useful tool that we need, and this is the only way that we can achieve it. Radars cannot look to the top of the atmosphere like a balloon can. Satellites look down, but the resolution is not good enough and it cannot derive all these different variables. So we need these weather balloons to get these data. The other thing that we do with it, not only interpret it in real time, but we put it into our weather models. So even our best weather models only update once an hour on the smallest spatial scales for us to know when rain is going to occur. So when those are somewhat off and incorrect, and twice a day, we take these weather balloon numbers and we plug them into all the models that we use, and it helps to correct the initial conditions, which leads to better forecasted products from things like the GFS, the Euro, the HRRR model. This is the information we need and what helps tell us what's going on. Weather balloons are critical, they're irreplaceable, and this is just a great example as to why.